Hey, this is the Chromatography Lab. Okay, chromatography is a method for analyzing mixtures by separating them into the chemicals from which they're made. It can be used to separate mixtures like ink, gasoline, lipstick. In ink chromatography, you're separating the colored pigments that make up the color of the pen. Even though a pen will only write in one color, the ink is made from a mixture of different colored pigments. All forms of chromatography work on the same principles. They all have a stationary phase, that's a solid or a liquid supported on a solid, and a mobile phase, which is a liquid or a gas. The mobile phase flows through the stationary phase and carries the components of the mixture with it. Different components travel at different rates. To perform ink chromatography, you place a small dot of ink to be separated at one end of a strip of paper. This end of the paper is then placed in a solvent. The solvent moves up the paper strip, and as it travels upward, it dissolves the mixture of chemicals and pulls them up the paper. The chemicals that dissolve best in the solvent will move up the paper strip further than the chemicals that do not dissolve as well. What is produced from this method is a chromatogram. Forensic scientists can use ink chromatography to solve crimes by matching documents or stains found at a crime scene to the marker or pen that belongs to a suspect. Forensic scientists analyze the unknown ink and compare it to writing utensils collected from possible suspects. To prove that an ink sample is a certain brand, scientists need to calculate the retention factor values, or RF values, of the different colored chemicals present in the marker. RF is a calculation that compares the distance that the solvent traveled up the strip to the distance that a pigment traveled up the same strip. Now, here's our crime in this situation. Someone keeps stealing my sandwich from the staff room refrigerator, so I left a polite note on the refrigerator asking for the perpetrator to stop because I get cranky when I don't eat. So I received a ransom note in return. After analyzing the handwriting, I've narrowed it down to 5 suspects. Suspect number 1, Mr. Hart. Suspect number 2, Mrs. Ogden. Suspect number 3, Mrs. Thun. Suspect number 4, Mrs. Susie. And suspect number 5, Mrs. Wiest. I have stealthily, under the cover of darkness, taken each of their favorite black pens. Now, I need your help to match the suspect's pens to the ransom note. Please help me find my sandwich, and I will serve justice. So to complete this lab, we're going to need filter paper. We'll get 5 different brands of black markers, plus we'll have our one unknown ink. We'll have scissors, we'll have large test tubes, we'll have paper clips, rulers, and water. Now what we're going to do is we're going to have the 5 strips of filter paper set up with a small 1/4-inch spot of ink. Black ink will place right at the bottom of that filter paper right there. Okay, and so that end is going to go into the water. Okay, so we're going to put in that water into that test tube. We're going to hook it up with a little cork stopper here, and we're going to hook our filter paper on it, and we're going to bring our filter paper down into this water here. And what's going to end up happening is this water is going to travel up the paper strip. It's going to hit this ink, and it's going to start spreading out that ink into its different components that make up that ink. And when we compare the 5 strips together, we'll be able to determine which strip was the unknown marker. Okay, so here is our lab setup. We have our test tubes and stoppers, we have our filter paper, and we have our 5 markers. Each marker is associated with a specific filter paper, and the filter papers are numbered to each marker. And we have 1 paper for our unknown marker. Once our filter papers are attached inside
the test tubes. This is the way it would look. They sit there, 1, 2, 3, 4, 5, and then the sixth one at the end is our unknown. And so we're going to add the water to the test tubes. Okay, the water has been added to each test tube. Each test tube was marked with the height of the water for that specific filter paper. So now we're going to put the filter paper back in the water. Okay, so the filter papers are back in the water, and you can see that the water's already starting to filter up through the filter paper, and you can see the ink beginning to spread out into its colors. Okay, so each pen used a different combination of pigments to produce their black colors. So look closely at each chromatography strip. How many different colors are present in each ink sample? Go ahead and pause the video, count how many different colors there are for each strip, and record that in the data table. So to prove that an ink sample is a certain brand, we're going to need to calculate the RF values, or retention factor values, of the different colored chemicals present in the marker. So first, look at the chromatography strip, and we're going to measure the distance in millimeters from the original color dot to the final point where the solvent traveled, the water. So the point where the water traveled is marked on each strip. We're going to go from where the colored dot was to where it ended. And so we can see for number 1, it measured a total of 8.5 centimeters. And so here is all of the distances that the solvent moved, which in the RF equation is the variable L. So number 1 went 85 millimeters, 2 went 81 milliliters, 3 went 90 millimeters, 4 went 85 millimeters, 5 went 80 millimeters, and our unknown went 85 millimeters. That's the distance that the water moved. So the next thing to do is to measure from the original color dot to the highest point of the first colored pigment. Like for number 4, that would be the highest point of the yellow. Okay, so that would come in here, right about here is the highest point of the yellow. And we're going to repeat that for each pigment on each strip. And so here is the data for that.
Okay, so here is the filled out data from the lab. And you can see, what I want you to notice is that the data table is filled from the bottom up. So you have colored pigment number 1 for each strip at the bottom of the data table. So you're going to fill it out like the pigments went up the strip, right? So you're going to fill out the data from bottom up. Okay, now this might be a little bit hard to see. So here then is colored pigments 1 and 2. You can go ahead and pause the video and fill in the data there. And then here is colored pigments 3 and 4. You can go ahead and pause the video and fill in the data from that. And now the next thing to do is calculate the RF values, and you'll use the total solvent distance for each strip, okay, and the data for the distance of each pigment to calculate the RF value for that specific pigment. If you have any questions, feel free to email me or come to office hours, or we can cover it in class.